Alright, these are our notes for section 7.2 on the Pythagorean Theorem, okay, which is something we should already know. We've talked about it before, but we're going to review it real quick. First question here is, what is the Pythagorean Theorem? It is a squared plus b squared equals c squared. Alright, now a couple things to remember. First one is this only works on right triangles. Okay, everything in this chapter will be dealing with right triangles. So the Pythagorean theorem, it will only work on right triangles. Second thing is that A and B are the measures of the legs, or the sides that make up the angle, the right angle. Okay, A and B are the measures of the legs. Okay, and the legs of the right triangle, again, are the two sides that make the right angle. Okay, they make our right angle. The last thing that you need to remember is that C is the hypotenuse. Okay, another way to remember that is that it's the side across from the right angle. Okay, so A and B have to be the legs of the triangle, the two sides that make the right angle. C is the one across from the right angle. It's the hypotenuse. And all we do is we substitute in our values for A, B, and C. Usually one of them will be missing, and we have to solve for whatever one is missing. And we've got 4 examples here. Okay, and it says to use the Pythagorean theorem to find the missing sides. There's one side missing in each one of these triangles. Let's start with this first one, example 1. We've got a right triangle here. We have x, 3, and 4. What you need to remember is which ones are A and B and which one is C. Now, to figure out C, what I usually tell people to do is to draw an arrow pointing out of the right angle. It will always point to the hypotenuse. So this one here, x, is going to be the C, the hypotenuse, in our Pythagorean theorem. So we're going to substitute in our values. Let's start with a squared plus b squared equals c squared. Okay, A and B don't matter which one is which. It doesn't matter. So I'm going to plug in 3 for A and B for 4. 4 for B. And then x needs to be c because it's the hypotenuse. And then we're going to solve this. Well, 3 squared is 9, and 4 squared is 16, and that equals x squared. 9 plus 16 is really 25. Now somehow we have to get rid of the square over here, and to do that we are going to root both sides. And then we need to break down the square root of 25. Well, that one's easy. The square root of 25 is just going to be 5. So there is our answer. Okay, the answer is 5. If it's not a perfect square under the radical, you still need to break it down. I want it in simplest form. It will not always happen that it's a perfect square underneath. Let's look at our next example. This will be example 2. We've got a right triangle. We have 3, D, and 6 as our sides. Now we're going to draw an arrow pointing out from the right angle. That's going to tell us what C is. So C is 6 in this one. We are not looking for the hypotenuse. We're looking for a leg. So we're going to start with the Pythagorean theorem. A squared plus b squared equals c squared. We're going to substitute in our values. Well, we know C in this case is 6. And then, like I said before, A and B, it doesn't matter which one goes where. So let's put 3 in for A, and then D in for B. Now I want to point out that this is your equation. On your worksheet that you're going to do for homework, you're going to have to write out an equation for me. I want to see that, so make sure that you are showing that step. Now we're going to simplify it. 3 squared is really 9, plus D squared equals 6 squared is really 36. So now we've got to get D squared on one side by itself. We subtract 9. D squared equals 36 minus 9 is going to be 27. Take the root of both sides. So D equals the square root of 27. And we need to break that 27 down. 27 can be broken down into 9 and 3. 9 is a perfect square. So 3, the square root of 9 is 3, is going to go out front, and this 3 stays underneath. We did have a label when we started, centimeters, so we need to make sure we put that on our problem. And then there is our answer to our question. D equals 3 root 3 centimeters. Let's look at our next example, this one here, example 3. We've got right triangle, 20 inches, 28 inches, and x are our sides. We're going to draw an arrow pointing out to the hypotenuse. That means in this example, the hypotenuse is x. So we start with a squared plus b squared equals c squared. Next step is to write that equation. A and b, again, it doesn't matter. So 20 squared plus 28 squared equals x squared. This is our equation. I do want to see that. So let's simplify it now. 20 squared, we'll probably need to put that in our calculator. It's going to be 400. And 28 squared is 784 equals x squared. We're going to add those two things together. 784 plus 400, well, that's going to give us 1184 equals x squared. Take the root of both sides. It means, and I'm going to switch these around, x equals the square root of 1184. Now we need to break 1184 down. All right, to break that down, we're going to go through our list of perfect squares. We're going to start with 4. We're going to see if 4 goes into 1184. And it does. It goes in 296 times. That's awfully large. I'm going to list that over here. 4 times 296. So let's see if there's something else. Let's try 9. 9 is the next number in our list. 9 does not go into 1184. It comes out as a decimal, 131.5 repeating. So let's try the next one. 16, 1184 divided by 16. That one's better. 16 times 74. I like that. Let's go with that. Square root of 16 is 4, so it is going to come out in front, and then 74 is going to stay underneath. Now I'm going to check and see if we can break 74 down. 74 is divisible by 2. So 74 divided by 2 is 37. Now we're going to stop there, and the reason we stop there is because 37 is prime. There is no way to break down 74. No perfect square goes into that answer. So the answer to this problem is x equals 4 square roots of 74 inches. We do need a label there because we had a label in our problem. We have one more example here. This one's a little different because we have radicals as the sides of our triangle. We're going to draw an arrow out from our right triangle. It's going to point to the hypotenuse. Our right angle is going to point to our hypotenuse. So our hypotenuse here is r. So we start with a squared plus b squared equals c squared. Let's plug in, and we're going to use parentheses this time, square root of 6 squared plus the square root of 7 squared equals r squared. Now what happens is when you square a square root is that the root and the square cancel each other out. So this is just really 6 plus, these cancel each other out, 7 equals r squared. 6 plus 7 is 13 equals r squared. Root both sides. So r equals the square root of 13. Square root of 13 is not going to break down. It's prime. So there's our answer. Okay, those are our 4 examples for using the Pythagorean theorem to find the missing sides of a triangle. Now we're going to go on and we're going to talk about the converse of the Pythagorean theorem. Okay, the converse of the Pythagorean theorem, remember converse means we switch the hypothesis and conclusion, so it's just going to be the opposite. For the regular Pythagorean theorem, we plug the sides of a triangle in to find, has to be a right triangle first, and we plug it in to find the sides. Converse is going to be backwards. We're going to take the 3 values and we're going to see if they make a right triangle. So it says if 3 values work in the Pythagorean theorem, then the values make the sides of a right triangle. Okay, so it's the opposite way of doing this. Instead of starting with the right triangle and finding a missing side, I'm going to give you 3 sides, and if it works in the Pythagorean theorem, then they're the sides of a right triangle. If it doesn't work in the Pythagorean theorem, then they're not the sides of a right triangle. Now we're going to add one more idea to this. If 3 values work in the Pythagorean theorem and they are all whole numbers, which means no fractions, no decimals, no square roots, then they are called a Pythagorean triple. Okay? We're going to add that question to our examples here. So for our 3 examples down here at the bottom, it says, do the values make a right triangle? And then the second question is, are they a Pythagorean triple. We're going to check for both. One thing before we do these examples is that you need to make sure you remember C is the largest value. The hypotenuse is always the longest side of a triangle, okay, which means it would have to be the biggest value. So C for all of these, when we plug them into the Pythagorean theorem, has to be the biggest number. What we're going to do on these is we're going to look at our examples, the three numbers they give us. We'll start with example 1. They have 12, 42, and 54. I just said C has to be the biggest one, and then A and B could be either or. It doesn't matter. So what we're going to do is we're going to take those values and we're going to plug them into the Pythagorean theorem. And we're going to see if they equal each other. Okay, 12 squared is 144, plus 42 squared is 1,764, and then 54 squared is 2,916. Then we're going to add 1,764 plus 144, and we get 1908 equals 2916. This is a false statement, okay? That does not work. The two sides of the equation don't equal each other. Since it doesn't work in the Pythagorean theorem, the answer to, are they the sides of a right triangle? No, they're not the sides. Since it doesn't work in the Pythagorean theorem, there is no way they could be a Pythagorean triple. Okay, so the answer to this problem is no and no. Let's look at example 2. Our three values are 9, 12, and 15. Well, the biggest one has to be C, which is 15, and then A and B could be the other two. We do the same thing. We're going to plug it in. 9 squared plus 12 squared equals 15 squared. Well, 9 squared is 81, 12 squared is 144, 15 squared is 225. And if you don't know any of all those off the top of your head, plug them in your calculator. So now we're going to add 81 and 144. We get 225 equals 225. Okay, this works. This is a true statement. So the answer to the first question, do these values make a triangle? Yes, they do, because it works in the Pythagorean theorem. Okay, if it works, then it's yes, they are the sides of a right triangle. The second question, are they a Pythagorean triple? Well, it worked in the Pythagorean theorem, so we have to go through and we check and see if they're all whole numbers. 9, 12, 15 are all whole numbers, so the answer to the second part is yes, they are a Pythagorean triple. So the answer to this one is yes and yes. Worked in the Pythagorean theorem, so it is they are the sides, and then they are all whole numbers. Okay, and in addition to working, since they're all whole numbers, then yes, they're a Pythagorean triple. One more example here. Okay, example 3, we've got three values, 8, 4, root 3, and 4. Well, 4 root 3, we don't really know what that is as a decimal, so we're going to go ahead and put it in our calculator. We're going to see what it is as a decimal. It's about 6.9, which means that 8 is our largest value, so it has to be C, and then these could be either or, it doesn't matter. So let's plug it into our Pythagorean theorem. 4 root 3 squared plus 4 squared equals 8 squared. Okay, 4 root 3 squared, this one is tricky. You have to square the 4, okay, which would be 16, and then the root and the radical, they cancel. So it's really 16 times 3, which is 48. Okay, you should know how to do that. We've done that before, but that is tricky there. Plus 4 squared is 16 equals 8 squared, which is 64. Let's add 48 and 16 together, and when we do that, we get 64. So we get 64 equals 64. That's true. This works. So the first question, yes, they are the sides of a right triangle because those values work in the Pythagorean theorem. Second question, since they worked, are they a Pythagorean triple? The answer here is no, they're not, because even though they worked, 4 root 3 is not a whole number. We got a decimal when we plug that in the calculator. So no, they are not a Pythagorean triple. So the answers here are yes and no. Yes, they are the sides because our three values work in the Pythagorean theorem, but no, they're not a Pythagorean triple because even though they worked, one of them's not a whole number. Okay, so those are your notes on section 7.2, the Pythagorean theorem. using the Pythagorean theorem to find the missing sides of a right triangle, and then using the Pythagorean theorem to check and see if three values make the sides of a right triangle and if they're a Pythagorean triple.